Hello everyone, I'm Shruti doing my research from University of Tasmania. The title of our presentation is a bio-hygrothermal mold growth analysis of typical Australian residential wall systems. The co-authors are Dr. Mark Dewsbury, Professor Hartwig Kunzel, Dr. Philippa Watson, and Professor Heather Lovell. The sequence of my presentation is introduction and background, method, results, discussion, conclusion, and further scope of research. To introduce the topic here, there are two newspaper articles. The first one is from Tasmania and the other one is from New South Wales. Though being different climate zones, the experiences of the occupants had been the same. They were forced to leave their habitable space because of mold infestation and adverse impact on their health. Since 40% of Australian contemporary code-compliant households face condensation problem, hence condensation is a national issue here. A methodology was adopted to establish likely causes of condensation and mold within the code-compliant contemporary houses. Here there are a few steps detailed out. The first step is to analyze the NCC guidelines on wall construction. The next step is to evaluate typical code-compliant common external envelope components. Here in this research, we have analyzed three different commonly constructed wall systems, which are brick veneer, weatherboard, and compressed fiber cement sheet. In this conference paper, we have discussed the results of a brick veneer wall. The next step is to analyze the results from the steady state and dynamic state hygrothermal simulation tool. In this research, the steady state hygrothermal simulation tool used is ISO 13788 compliant JPA software, and dynamic state hygrothermal simulation tool used is WUFI. Then the next last step is to analyze the results from the mold growth model, which is the primary focus of this paper. The mold growth models are the crucial add-ons available in WUFI, which are WUFI VTT and WUFI Bio. In this conference paper, we have discussed results derived from WUFI VTT. This slide shows the wall sectional details as per the building regulations pre-2003 to 2019. The first diagram shows pre-2003 version 1, which comprised of brickwork, air gap, and plasterboard. Pre-2003 version 2 comprised of brickwork, pliable. There is an addition of a pliable membrane, which could be a vapor permeable membrane or a vapor impermeable membrane. Then we have the air gap layer and then the plasterboard as the innermost layer. 2003 to 2019, the construction details remains to be the same. Just there's a change in the insulation level as per the building regulations. In 2003, the insulation level within the wall system was R1, and currently from 2010 to 2019, the insulation level within the wall system is R2.7. This slide shows the wall sectional details as shown in WUFI. From left to right, it shows the outer layer to the inner layer. The outer layer is the brick layer. Then we have the air layer. Then we have the pliable membrane. For this conference paper, the pliable membrane used is vapor impermeable membrane. Then we have the insulation layer, and finally the innermost layer, which is the plasterboard. Here in this top graph, the red line shows the temperature fluctuations, and the purple line shows the vapor pressure difference from the outer layer to the inner layer. This green line shows the relative humidity fluctuation, which ranges from 20% to 100%. And the blue line shows the moisture accumulation within the different layers. Here the moisture accumulation is evident in the brick layer and the air layer. Mold index are the indicators for empirical validation in the VTT model, which ranges from 0 to 6. The mold index of 0 is described as no growth. 1 is described as small amounts of microscopic mold growth on surfaces. And 2 is described as several local colonization of microscopic mold growth. 3 and 4 is described as visual results, which ranges from less than 10% to more than 50%. 5 is described as high colonization of mold growth on surface, which is more than 50% coverage. And 6 is described as very high and tight colonization of mold growth on surface, and the coverage is about 100%. The bio-hygrothermal results shown in WUFI VTT is in the form of traffic light classification. When the calculation period is less than 1 year, we do not achieve any results, so the calculation period has to be more than a year to attain the results. When the results are shown in red, then the mold growth, in that state, the mold growth exceeds 200 millimeter per year. This corresponds to the mold index of approximately 2. These results are usually not acceptable. Then when the results are shown in yellow, mold growth is between 50 millimeter per year and 200 millimeter per year. There's an additional criteria of investigations required for assessing this acceptability. And then when the results are shown in green, the which is below 50 millimeter per year, and this corresponds to a mold index of approximately 0.5. These results are usually acceptable. This slide shows the results of the brick layer within the brick veneer wall system, and this simulation is carried out for a 10-year span. This is done for climate zone 7, Hobart climate, and this is done as per National Construction Code 2019 regulations, which is for the 7-star. And then the result for this layer we have achieved in red, which shows unacceptable results. And this red line shows the temperature fluctuation within this wall system for the duration of 10 years. Then the green line shows the relative humidity fluctuation, which is again 20% to 90%. And this graph shows the continual mold growth within this layer. And this the below graph shows the mold index of 4 to 4.5 within this layer. This graph shows the results of the air cavity layer within the brick veneer wall system. This graph shows the result in red. This is again for climate zone 7 NCC 2019 regulations. There's a continual mold growth shown in this layer, and the mold index for this layer is 5. This graph shows this slide shows the results of a vapor impermeable membrane layer. The first graph shows the results in red even for this layer. Then the next graph shows the continual mold growth, and the third graph shows the mold index of almost 3 to 3.5 for this layer. This slide shows the results for the insulation layer. Even for this layer, the results are shown in red for the climate zone 7. As per the NCC 2019, there's continual mold growth in this layer, and then the mold index of this layer is 5. This slide shows the plasterboard layer results. This the first graph shows the result in green. There is no mold growth rate, and the mold index is 0. Again, when we started getting results in red for the NCC 2019 regulations, we did a multi-layer analysis. So this is the first base model results which we had conducted the experiments on. Then we had an addition layer of analysis done, that is with the addition of moisture source. And here, as per the laboratory testing done at UTAS by one of my fellow PhD friend, he has found that even in the laboratory testing, the moisture is being accumulated for a pliable membrane, irrespective of irrespective of permeable or impermeable. Then this is the third level of analysis which we have done, that is with the addition of latex paint. This paint is added to the inner portion of the external layer, which is the brick veneer, which is the brick layer. And then the final stage of analysis we have done with the help of the addition of latex paint and vapor permeable membrane. So latex paint is added here, and the permeable membrane is added to the inner portion of the plasterboard. And then these are the results based on the different layers of analysis. This is the base model result, and with the addition of moisture source, with the addition of latex paints, latex and permeable membrane. And then on a recurring basis, we were getting results in red for the west orientation, but for the 7-star NCC 2000, as per the NCC 2019 regulations, we constantly started getting results in red for all the orientations. And then these are the results for the vapor permeable membrane. This again, the experiment was conducted for the span of 10 years. And on a recurring basis, we have got results in red for the west orientation. And then as per the NCC 2019, we started getting results in red and yellow. So here, to conclude, the results indicate that this facade system is simulated in NCC Climate Zone 7 and designed as per 6-star compliant manner will promote significant moisture accumulation and mold growth in some orientations. But as per the 7-star standards, all the orientations are having evident moisture accumulation and mold growth within the wall system. And then this research identifies that this wall type, which comprises more than 57% of the contemporary dwellings, requires further research to establish what material configuration should be adopted so that moisture is not accumulated and mold does not grow. This is the video from WUFI. It shows the red line shows the temperature fluctuation, purple shows the vapor pressure difference, the green shows the relative humidity fluctuation, and this blue shows the moisture accumulation within the different layers of the wall system. Thank you.